Good day, I am Mark Lawrence V2.0 and I am going to perform the laboratory activity, which is this network switch configuration. Before proceeding to the activity, just a disclaimer, this presentation is for educational purposes only and does not constitute any legal advice. It is recommended that you seek legal counsel for a specific matter. All copyrights and trademarks of music, videos, images, and information belong to their respective IP owner and are used under fair use for educational purposes. So as I was saying, I will be performing the laboratory activity, which is the network switch configuration. One of the requirements is the Cisco packet tracer software and the laboratory instruction handout, which you can see the left side of the monitor. So it's the application starting. We have an objective to set up a local area network using network switch, to use data network simulator software, to establish network of switch and computers, and to be able to explain common technical concepts in switch configuration. Let us proceed to the application. Let us place it at the right side of the monitor. Okay. Let us proceed to the procedures. Number 1. Using the software, construct a start topology with a switch and 3 computer nodes. Let us drag and drop a switch. Let us zoom it to have a bigger display. And 3 computer nodes. Just drag and drop from library. Okay. It's up to you on how you will place the computer nodes in the switch. For me, I prefer these placements. So we are going to use the straight through cable to connect the computer node to the switch. For PC0, for PC1, and for PC2. Okay, I think this is good to go. Number 2, configure the network by assigning the IP addresses and subnet mask as follows. So for PC0 rather, let us, there is a 192.168.1.0.10, 192.168.1.10. The subnet mask will be 255.255.255.0. Next is for PC1. IP address will be 192.168.1.11. Same subnet mask. And for PC2, we will be using the IP address of 192.168.1.12. Same subnet mask. Okay, that's good to go. Next procedure, use the ping command to test the connectivity of each pair of nodes. So for PC0, we will ping PC1 and PC2. For PC1, we will ping PC0 and PC2. And for PC2, we are going to ping PC0 and PC1. Let us proceed. From PC0, we are going to use the command prompt. Configure first the PC. So this PC uses an IP address of 192.168.1.10. So we're going to ping the PC1, which uses 192.168.1.11. Uses 32 bytes of data. ping statistics 0% loss, and the approximate round trip average of 0 milliseconds. Next one, we're going to ping the PC2, which uses 192.168.1.12. 32 bytes uses 32 bytes of data, ping statistics 0% loss, and the approximate round trip average of 0 millisecond. So that's enough. So we have seen that the connectivity of PC0 to PC1 and PC2 is good. Next is for PC1. We are going to test the connectivity of PC1 to PC0 and PC2. ipconfig. The PC1 uses 192.168.1.11. We are going to ping PC1, which has 192.168.1.11. .10 rather. Uses 32 bytes of data. Ping statistics 0% loss, and the approximate round trip time in milliseconds. The average is 0 millisecond. Okay. Next, we are going to ping PC2. .12. Okay. Ping statistics 0% loss, approximate round trip 0 millisecond. Okay. We have tested that the connection of PC1 to PC0 is good, and as well as from PC1 to PC2. Lastly, the PC2, we are going to ping PC0 and PC1. ipconfig. The PC2 uses 192.168.1.12. We are going to ping PC0 okay. The ping statistics 0% loss, approximate round trip is 0 millisecond. The average. Next, we are going to ping PC1 192.168.1.11. Okay. The ping statistics says 0% loss, approximate round trip average 0 millisecond. So we have seen that the connection of PC2 to PC0 and PC1 is good. Next procedure, after the establishment of connections, send PDU from PC0 to PC1 and observe the network response through simulation mode. By the way, PDU stands for Protocol Data Unit. It is a single unit of information transmitted among peer entities of a computer network. So, PDU is composed of protocol-specific control information and user data. So, from procedure 4, we are going to use the simulation mode. It's located at the bottom right of the application. Just click simulation, show none to disable any other types of PDU. We are going to check the ICMP. Stands for the Internet Control Message Protocol. So the ICMP is a transport level protocol which communicates information about network connectivity issues back to the source of the compromised transmission, and it sends control message such as destination network unreachable, source route failed, and source cache. So let us proceed. Just click at the upper portion of just click add simple PDU, click the sender, PC0 to PC1, the recipient. So let us activate here the PDU list window. We can see that the source is PC0 and the destination is PC1. Status in progress. Make it lower. Let us play. So PC0 sent it to switch, and the switch sent it to PC1. It got a reply back to switch 0 and then back to PC0. The status says that it is successful for only how many of that? 4 milliseconds. Next procedure, observe the network status and the flow of PDU. So it says that it is successful and it sends from PC0 to switch, and then the switch sent it to PC1 and back to the switch 0 and then back to PC0. Procedure number 6, repeat procedures 4 and 5 for PC0 to PC2. Let us try just to the packet tracer says a buffer. Going to clear and list. I hope I'm doing this right. Okay, let us click send a PDU from PC0 to PC2. So I think we are going to establish two processes. It will be from PC0 to PC1 and PC0 to PC2. Okay, let's see. Let's play the simulation. It first sent from PC0 to PC1. It also sent to PC2, but it does not receive it since the recipient is PC1. Also, the PDU from PC0 was not received by PC1 since the recipient is PC2. The PC0 successfully received the PDU which was sent by PC1. Also, the PDU sent back by PC2 was received by PC2 in a span of 5 milliseconds. Both processes was successful, as we can see in the PDU list window. I think that's good. The next part will be the questions. Okay, I will just place it in the document, which it briefly discusses the PDU, ICMP, and STP. By the way, STP is a spanning tree protocol. We haven't covered it in this activity. I think in the next activities we are going to use the STP. Clear event list. Number 2, explain the network response and data flow in procedure 4. And number 3, explain the network response and data flow in procedure 6. So I think we have covered it previously while the simulation is playing. So that will be all for this activity. Thank you very much for listening and good day.